Hi, everybody. If you've ever seen me present before, I normally wander around. I would use this entire front space. I have a broken toe today, so I'm going to present seated. And I ask you not to judge me because walking on this toe hurts, okay? I also have a cold today, as you might have heard, and I will likely blow my nose multiple times during this presentation. I'm all the way up here. I promise I won't get anybody dead. Okay, these are the challenges. So I ask for your patience and grace as we start off today. So it's already been mentioned. I've been with Improving for 14 years. I've been designing distributed systems though as the vast majority of what I do for my career. So 20 plus years, really focused on building systems where one piece of hardware has to talk to another piece of hardware all to get something done, okay? At more than connect to a database level, okay? I have authored a book on NA Framework. I'm a barbecue geek. I'm a Magic the Gathering geek. I'm a former D&D podcaster. Yes, I swear, for like 4 years. I'm a soccer fan. So pretty much if there's a geeky thing in the universe, I probably do it. So the goal today is we're going to talk about two great tastes that taste great together in software. That being MassTransit and Kafka. So let's start, while all that's up here is what is MassTransit and what is Kafka on the agenda, by asking how many people are familiar with MassTransit already? Okay. And how many people are familiar with Kafka? Okay, so about the same number of people. Yeah. Wait for it. Might be the most slides I have in this entire presentation. Okay. All right. So we'll talk through what is MassTransit, why do you care, why am I talking about it in combination with Kafka. Then we're going to talk about what Kafka is. Okay. And then we're going to spend a lot of time on the space that is called streams are not queues, and we talk about what exactly a stream is, why it is different than a queue, okay, and why, despite this fact, MassTransit, who is most well known for being a queue-based thing, works and can work with Kafka perfectly well. Okay, that is the agenda. If at any point I become boring, feel free to walk out. Okay, so what is MassTransit? I have been talking about MassTransit since almost the day after I learned about it, okay? It happens that this very, very popular open source framework was written by a gentleman who at the time lived in Tulsa, Oklahoma. I was traveling and speaking a great deal around the region, and so Chris Patterson, who writes MassTransit still to this day, and I moved in the same circle. So I found out about MassTransit fairly early on in its work. For the longest time, it actually is no longer true, just very recently, Chris's claim to fame was that he was a chief software architect for this company nobody's ever heard of called McKesson. Basically, if you do anything medical going on in the world, McKesson is a vendor for you, right? They probably, if you go to your doctor's office, are involved in getting your doctor paid, okay? They do a ridiculous amount of things spread across a huge amount of space. They ship pharmaceuticals. They do all sorts of other things in healthcare. And because of this, they have a lot of systems that are disparate and geographically spread that all need to talk to one another. And Chris really used the needs of McKesson to drive the development of MassTransit, okay? Where he was like, I want a library that makes all of the trouble of consuming from queues and publishing and doing pub sub type publication. I want that all just to go away. I just want the pain to go away, and I want one library to handle it for me. Unfortunately, that library did not exist, so he wrote it instead. Okay, so in my opinion, what is MassTransit is solid gold, it's solid gold, but in more detail. It does at least these 5 things that are stupendously important to you if you are building a distributed system. The first is it handles message distribution at an abstraction level. Okay, so it has the concept of a service bus. I can send a message out and subscribers to that bus can receive it without the publisher having to know who is going to receive it. That entire abstraction happens behind a set of facades and abstractions in code that mean you don't even have to know what your queuing technology is. If you are the person writing business logic for mass transit. If you're the person setting up mass transit for the first time, you obviously need to know what to tell it to connect to. Okay? But if you're just like, go in, it's a mass transit solution, I'm going to add a new consumer that's going to do some new business work for me, you don't care. None of your business code is even aware of the queuing technology you're using to send the messages. It gives you complete ignorance around that. Related to that, it gives you this message consumption abstraction, which is to say, once a message has arrived to you and you've dealt with all of the challenges of getting it off the queue, of handling it appropriately, etc., mass transit is there to say, here is a consistent way to consume a message. We're going to give you a message into this interface, this way, register these with your dependency injection, and they will always get messages delivered to them that they need. It also has a workflow engine. It also has service process monitoring, which is to say, anybody can go read the help on RabbitMQ and write the loop necessary to monitor a queue for a new message. Very few people can deal with the fact that your network went flaky and you need to reconnect, okay? That there is a network interruption in the middle of receiving a message, okay? That you just get a poison message and you need to retry it. All of these challenges, all of the edge cases that come out of network communication have already been handled for you in mass transit, okay? You don't have to worry about that. If you're doing work and your code throws a fault and all you did throws an exception, right? You're going to throw an exception out of your code because you didn't handle this particular scenario, and you go and you're like, oh, but I didn't put any bulletproofing in my code, so it just bubbled straight up out of my consumer. Mass Transit's going to be like, no problem. I caught that exception. I requeued the message. It got retried by default infinitely. You can, using the service process monitoring pieces, you can say, hey, only retry these 5 times before we send them to a dead letter queue or something like that. It has all of that built in. So you didn't have to think about it. You just can come in and go, this is what I want to have happen. Okay? Because smarter people than me have already done that. And then on top of it, it has all of the open telemetry and state and health management pieces that are necessary to make it so that how your distributed system is working and how it is running is visible to all of the operational systems that are going to be necessary to monitor something that's using all the network activity and doing these things. This is what mass transit gives you. Okay? You had me at I don't care about my transport layer, right? Like, give me PubSub without having to care that I'm on SQS versus RabbitMQ versus Azure Service Bus. Like, just giving me that abstraction makes it worth it to bring this library in. Okay? The fact that it's entirely open source and you don't have to pay anyone for anything on it, all the better, right? All right. So, you've seen my example. What's Kafka? So I'll ask the room, what is Kafka? Someone give me an answer. Huh? Log? Okay. Somebody else give me an answer. Not because you're wrong. Distributed log, an excellent upgrade to a log. Okay. So I'm for sure going to rankle some feathers here. Agreeing and also disagreeing with my friend in the back row as I go. My one-word answer to this is Kafka is a database. Okay. Now this here is fighting words, and I could see the fight already in the back row. Yes. Yes. I'm sorry for those who happen to sit too close to David as I do this. Yeah. That's fair. Yep. All right. So why do I say this? And this is contentious. First of all, I want to say there are lots of people who use Kafka in a transient way. Okay? They use Kafka like it's a queue. Kafka is not a queue. Okay? And we're going to go into a lot of details about why it's not a queue as we continue on. Okay? My long story version of what Kafka is Kafka is a distributed topic-oriented message log. Okay? Which, yes, David's right. It's a log. Okay? But I want you to take a step back and think about this in ways that are probably more familiar to most people in the room. How many people have worked with SQL Server before? Okay. How many people are at least conceptually aware of what the transaction log is? Right? Okay. So we tell SQL Server to do something, right? Two things happen for sure. It does the thing and it writes it in the transaction log. Like, these two things have to happen. They happen atomically, right? We know that they are going to occur. All right? So, which of those two things is more important? The data or the translog? Hands down the transaction log, right? With the transaction log, I can rebuild the data. With the transaction log, I can, if I know where I am in the transaction log, I can get the data up to date to any version that I want it to be up to date to. Okay? If I am so lucky as to have transaction logs ad infinitum back to the origin of the database, I can literally completely time slice the history of that. Stepping backwards on that very forwards only cursor line is expensive, but I can. Okay? Somebody who's like, but you can't just undo that command because you don't know what was there. I said I had all the data, so I do know what was there if I go all the way back to the beginning and rebuild only to that point. Okay? So we do this concept of what is Kafka? Kafka is a log that we can all write to, that we can only append to the end of, much to the chagrin of my friend Michael Perry, who is a fan of graphs. Kafka logs are a straight line. Okay? So if two of us try to go right at the exact same moment to the log, only one of us is going to get in first, and then the other one's going to get in first. Very much like a database, right? Very much like their database statements are executed in order, right? They're going to happen very, very quickly, but they're going to happen. So this concept of I have a high-speed log that I can write to, that actually, if you look, if you have a Kafka stream, which is actually what they call their logs, that stream is only a sequence of bytes. Literally all Kafka believes it must know about that is the byte length of the content. Now, if you give it more than that, goodness gracious, will it help you? Okay, but by default, all it says is, I'll take any stream of bytes and start sticking them in like log entries down this log. Okay? Like most databases, it lets you apply schema to go, hey, there are various types of things I can stick on this log, and each of them has a pattern, and you will obey that pattern to put something on that log. Okay? It will even, if you follow their Avro format, or if you follow JSON, will let you execute SQL statements against the resultant set of the projected outcome of their stream. Okay? So all of this to me says Kafka is the database taken to a world where the concept of a CQRS system is ubiquitous. This concept that we are splitting the responsibilities of write and read to completely different concerns. Okay? Because the thing you've experienced in SQL Server that isn't the transaction log, that thing that we call tables, right? All that is your first read projection. Okay? It is one form of a way to look at that data. And we have built CQRS systems on top of relational databases where we write into the write store and then message off into some system to allow somebody else to gather that data up and find a new projection that is relevant to their business problem and keep a copy of that and have a new read projection. Okay? So why does our write store have to have a read projection? And if we take a step back and go, our write store doesn't have to have a read projection, Kafka is the result of that concept, that idea applied to a database. So that's why I say Kafka is a database. Okay. Is it actually a log? It is actually a log. This is my case. Any questions about that? Because that is, for most people, even people who have been familiar with Kafka, me coming in and calling Kafka a database is usually enough to make them blow their mind and go, what are you talking about? Kafka stuff goes away in 3 days. I literally had a client tell me this. All topics are purged after 3 days, right? And it's like, no. Okay, disagree. So, questions about this piece? Darren. So, you are guaranteed acidity on writing a message, okay, entirely. So you can write to the head of the topic, guaranteed. You have ACID for that, okay? Acidity on read projections, it's less of a thing, right? But there are very few read projections in a distributed system where you get all of ACID, okay? That is correct, and we could certainly dig into that if we get to the Q&A piece. But what I would say at a high level to that topic is you shouldn't, if you're using topics correctly. This is why I say it's topic oriented, right? This concept of we should get ourselves out of the concept that I'm doing row-based data operations into this. I want to think about this log at a business operation level. And once you start thinking at that level and start thinking about your topics at that level, the need for places where I need to do two things simultaneously, okay, at two exact moments in time, definitely do wind up less, right? Now, certainly there is the sort of canonical transactionality example of I have a stream for Nick's bank balance, and I have a stream for Russell's bank balance, okay? And he's going to write him a check, right? So I'm going to deduct it out of Nick's thing, and then I go stick it in over here, right? And in that situation, right, there is a way that I can do those operations that will get me in trouble, right? But even in that situation, while traditionally we'd say wrap that in a transaction, do it all as one big thing, really all I care about is whether Nick has the money at the point at which I go to do the write, okay? Because it's a positive side move over here, right? So there's no data validation challenge there for I'm overdrawing Nick, etc. So again, thinking at that next level, right? Even with I'm withdrawing money from an account, even there, you can get away from the hard need. But you are correct. Can I write multiple times and commit to the head of two topics at the same time? You cannot. Okay. Other questions on Kafka at a conceptual level. All right. Let's talk about queues. All right. So I start here because most of us are familiar with queues. And it is very common for people to associate and go, streams are just like queues. Okay? Streams are not like queues. And we're going to go into why they aren't and where the challenges are. So I'd like to introduce you to some friends that are going to be with us as we go through this section. This is Fred the consumer. Okay? Fred consumes messages, literally eats them. Okay? So talking about the mechanics of a queue, the first thing we need to remember is queues are FIFO. When something new comes in as far away from Fred as it can be, right? It's going to go on the end, okay? And so and then Fred is going to start consuming off of this, right? Which brings up the next thing. Queues are durable but transient, okay? I put something onto a queue, it will durably be preserved on that queue. But once I am done consuming a thing off of the queue, it just goes away, right? It is no longer. This, in turn, so Fred has now eaten his message. This, in turn, allows queues to be a very good solution for when there are multiple threads, okay? Because of the fact that this is a pattern you'll see in queue-based systems called the competing consumer, okay? These two threads can each get a message, right? And do their thing. And life is good. Now, if there's a timeout, there's an exception. If there's some reason why the queue thinks that the process is going badly, right? Timeouts wind up returned to the head. So if we have two threads and they're consuming and they're doing their thing, and one of them gets 6 fall down and dies, okay, then the message being consumed by that thread goes back to the head of the queue because it was never successfully consumed, okay? The existing thread finishes with his message. He gets the message the other thread had, consumes it, okay, and then starts chugging through the rest of the queue. These are not all of the qualities of a queue. These are the ones that are importantly different when we start talking about Kafka and what a stream is. Okay? So let's talk about a stream. So it's a log. We have this time, right? We write a new thing in new time, right? The important thing here is that the time going on, we write to the end, right? We constantly are writing to the end of this log. So it feels FIFO, right? It feels like this first in, first out. But this is a misnomer because of the fact that the O is a lie, right? It goes back to the durable but transient thing we said about a queue, right? Nothing ever leaves a stream. Nothing ever leaves a stream. And this matters when we then look at how consumption happens. Because consumers do not read from the head of the queue. They do not talk to somebody who is dispatching it, which the queue server is handling for us in a queuing situation. I say, give me my next message. I don't say, give me message XYZ. I just say, give me my next message. It knows the next unlocked message will hand me the message, okay? In Kafka, all reading is handled as an offset from the start of the log, right? So you're going to come in and you're going to say, I want to read. Now, let's go with some fun, weird defaults. You're going to build this and then build client software for it, right? What would you make the default offset you start at? For me, I would make it 0. So you start at the start of the stream, right? You're going to get to see everything. If you don't tell most of the Kafka libraries to do anything different, they're going to go find out the length of the stream and make your requested offset the end of that stream. So you're going to immediately go say, is there anything there? And go, no. There might be 2 million messages there, but they're going to be like, no. Literally, there's nothing there. Okay? Now, there's a chain. There are bad defaults. I'm a big fan of Scott Hanselman saying from years ago, I want software that falls into the pit of success, right? I have a disagreement about this default because it's a bad default, okay? Not because of the fact that it shouldn't be configurable. It's a reasonable thing to say, I probably only care about logs from here forward, etc. So consumers reading from an offset mean that Fred goes to 0. Okay, and then when Fred is done reading 0, Fred moves to the next one, and the next one, the next one. Now, importantly, Fred is responsible for maintaining offset. Okay, your offset is your problem. Asterisk. Let's talk about the asterisk. Kafka will help you with that, if you would like. You can walk up to it and go, hey, I don't want to bother with that, okay? So I'm connecting to you, and I'm the system known as payroll, okay? And it'll go, cool. I'm going to note that you're payroll, and I'm going to keep a completely hidden from you log where I will keep track of your last offset. The trade-off to that is that literally anybody else walking up and saying, hey, I'm payroll, okay, is going to get the same number to the last thing you successfully read. Okay? This breaks competing consumer. You cannot have 2 systems actively reading through the history. Okay? Because of the fact that it doesn't work. They're either reading the same message, right? Or they're reading the whole history separately, which is what they should probably be doing, okay? Again, not a queue. In the situation that we have 2 readers, they're sharing the key or sharing an offset via a Redis location, or choose your way of getting around, I now have this integer I care about that is offset, okay? How do I deal with that? And I have somebody who's processing one piece, and then I've managed to get the next piece to the next one, right? If one of them dies, there's no picking that back up. It was read, the offset got incremented, the Fred who is behind is going to just leap over the bad message, the unprocessed message, okay? So, however you come across a bad message, ideally, obviously, you would not like something that is a bad SQL statement in your transaction log, so to speak, right? Like, you don't want a log message that is fundamentally untrue, but we've all met the fact that software will sometimes not get updated, schemas will modify and change over time, right? In the fullness of time, you will run into a entry on a stream that your software may not be capable of understanding. And if that happens, you have one option. Skip it. That's it. There's your one and only option. There's no putting it in a dead letter queue, right? There's nothing else because it's permanently there. And it will be there the next time you go read through the whole history again, okay? Because it's a database, and that is part of history, all right? So, none of these abstractions make Kafka in any way, or none of these realities, none of these choices of its implementation make Kafka bad. They make Kafka not a queue, okay? And a lot of organizations attempt to twist Kafka around to become a queue. It is a reasonable message delivery platform. It is not a queue, okay? And so we need to acknowledge what it is, acknowledge the behaviors that it wants you to follow, okay? Just like I would not ask a queue to provide me an easy way to always have access to all messages from all time, I should not expect a stream to be a queue. Okay, I should accept it for who it is, who and what it is. This makes sense to everyone? Okay. Good news, 3 slides left. Lots of code coming, I promise. We're done with Fred. Okay. So what does this mean for our friend MassTransit, right? MassTransit looked at the popularity of streams coming up, and they were like, wow, okay, there's some interesting aspects to this. But at its core, at the time, MassTransit was a service bus and had an expectation that its primary communication medium followed the semantics of a queue, okay? And yet, a lot of the things beyond that first bullet point, consistent error handling, consistent consumption structure, okay, telemetry, all of those things were things MassTransit had solved that people needed for working with Kafka, Event Hub out of Azure for a non-Kafka answer in the same space, etc. Some sort of stream solution. So Chris was like, I'd like to support Kafka, but I don't want to give up so much of what is core to MassTransit in the fact that its service bus really requires the semantics of a queue to do its work. And so they created what has become known as writers. Okay? A writer is a way to walk into a MassTransit setup and go, I would like to provide you an additional source of messages that you will be able to read from and handle and dispatch to your consumption infrastructure, dispatch to consuming code, all right? And we're going to provide this writer abstraction in a way that you don't care what's on the other side of that writer abstraction. But we need to recognize that it is not technically coming out of the bus, okay? Which means where that is most relevant is when you want to write back to the source of one of your writers. So you want to write to a topic and add an entry to a log. We need to not use the words publish, which is a method name in MassTransit that says, please send this to the bus, okay? And because MassTransit already had a abstraction for dealing with direct request response between 2 nodes on its bus, because sometimes you just need to not involve the bus, you just need to talk to another person. They also had another verb they couldn't use, which was send, okay? Because send was a verb they had already used in their library for that, okay? So the option was instead that they will, while consumption, you don't care where the message came from, right? If you want to send back to a writer, you want to send out to a writer, your choice is going to be a method name by the name of produce. So you're going to produce back to a writer, okay? So if you've ever seen any MassTransit code or if you've seen anything like this, you're going to, at some point in the next section here, you're going to go, what's that produce thing? The answer is, there you go. The other thing that they needed to deal with, they were like, well, you literally can't make MassTransit. You can't start a host process without a service bus. It is not possible. So what if people only want to use Kafka? What if they just want to get messages and dispatch messages back to a topic, never caring about a queue, because they don't want a queue in their entire system? And the answer to this was amazingly elegant. So this is where I take a side break and tell you a little bit of a story. There's this smart dude, like this absurdly smart dude who hangs around here in Dallas from time to time. His name is Amir Rajan, okay? Amir is stupid smart. He's spoken here multiple times, okay? And I maintain a open source framework for over entity framework by the name of Highway Framework. And because he worked at improving at the time, Amir was being forced to use it. For sure the answer was forced to use it here, okay? And he took the opportunity when myself and my co-author were in town to take us out to Smashburger in Addison and give us the litany of how bad it is to write code against our framework, none of which had to do with the production code he was writing. He hated how he had to unit test our code. We got affronted because we literally wrote this library to make unit testing against entity framework not suck. So we thought this was actually a strength. And so when somebody walks up and pokes you in the eye and says your strength is a weakness, you might not receive that well. We might not have received it well at the time. So they're like, okay, right, Amir, you're crazy, but okay. But he made a point in that lunch that eventually got through the thick skulls of Devlin Lyles and myself, which was, if you write a library that is going to be consumed by other developers, and those developers are going to have to do testing against your library, you should ship the stub. It's my 3-word banner phrase taught to me by Amir, okay? You should write the testing replacement for your library that doesn't require your other developers to mock every single interface that you decided to create in the creation of your library, which is what we were doing at the time, which, to be clear, was leaps and bounds better than any framework, because at the time there was no such thing as an IDB set. There was no way to mock a DB set. And so we had already done lots of good work to make testing better. Why should he care about doing this? We got there, I promise. Sometimes we're slow, but sometimes we get it. So we went through all of this to go, eventually, our Highway framework shipped an in-memory database of its own, distributed acyclic graph and all, that made it possible for us to record the results of the link statements that were being executed without an actual entity framework, without a SQLite, without anything else. We could run very, very fast unit tests, and we shipped it inside. I do not know whether or not it took Amir having the conversation with Chris Patterson, who writes MassTransit. But the good news is that MassTransit, for some time, has had an in-memory version of its bus explicitly there for unit testing, okay? And for a long time, it existed in a separate library called MassTransit.testing, okay, to go do its thing. And Chris was looking around for, like, how do I solve this writer problem of what if people only want writers and they don't want a bus? And he was like, wait, I've got it. Just grab my unit testing stub that I wrote and slide it into my main library. And so if you are in that situation, you simply initialize MassTransit by telling it, yeah, use in memory, okay? If, while having made that choice in your MassTransit config, you tell it to use in memory for its bus, okay, you ever actually do a publish which goes to the bus, it is on you for the fact that never left your process, okay? But for sure, and to be clear, for sure you can do that if you, for some reason, wanted to, okay? But what it did do was give him a nice way to get past all the setup stuff that required there to be a bus there, okay? Get all the plumbing in, build all his middleware places that eventually the writers are going to also use, okay? To be clear, when consuming, this in-memory bus has nothing to do with your consumption structure, and you must successfully end your consuming code before your offset is moved forward, which is the only thing that actually matters, as we just got them describing, moving forward the offset, okay? So the fact that your transient is no more transient than all the code that's running in memory, right? Like you're using in memory doesn't matter, okay? What it does is it gets a bunch of blockers out of the way to initializing MassTransit properly. With that said, let's show you some code that does exactly that. Let's come here, let's do this. Go to my desktop and switch to duplicating my displays. 1 moment. The thing I always have to remember to do when I switch to Visual Studio. Okay. All right. So our friend, Mr. Patterson, over at github.com/MassTransit, has several samples built, one of which is MassTransit/sample Kafka. The code I'm going to show you today is mostly this code, okay? Why mostly? Because of the fact that this code has none of the keys included to actually connect to a Kafka, okay, or actually connect to a MongoDB, which this sample does, okay? Chris has a YouTube series, conveniently linked in this README over here, that walks through exactly how to get this set up and running. He uses Confluent Cloud to do his Kafka. He uses Atlas to do his Mongo, so you don't even have to have him running on your box. It just does the thing, okay? But my code that I'm actually showing you here today is in a private repository because I also don't want to give you the keys to my private cloud environment. I know I'm unreasonable this way, okay? So I would point you back to this code and go, all I changed were the app settings necessary to make this actually connect to our environment. Importantly, yes, here in Confluent Cloud, which apparently is secure enough to have logged me out because I sat too long talking with you all. In Confluent Cloud, I have set up their free tier of a Kafka cluster that has 2 topics on it. One is events.erp, and the other is events.warehouse.47. Okay? They are both empty at the current time. I have not even run this code yet against this environment. I have run this code before. I have not run it against this environment for lots of reasons, including the fact that I needed to update my Visual Studio on this laptop, apparently, and so it got done 2 minutes before we started. So we'll see. Okay. The thing that I've done is I've set up a database in cloud.mongodb. This is just going to be a location where we can stick a database. Okay. So if we come over here, we have a database, and there are inside of this database 0 collections at the current time. Okay. And 0 databases at the current time. And I think actually the no databases is probably a problem for me. Let me double check. Hey, there's all the numbers I wasn't supposed to show you. Okay. No way. Okay. If I get a Mongo error, I'll deal with it. Okay. I think I might have to create a database here. All right. So the solution in here has 5 projects. We're going to start by caring about sample backend. Sample backend, which I'm setting as our startup project, is the thing that is reading messages in. Okay? And so it has a created default builder. It configures for Serilog, and then it goes, hey, let's configure services and add MassTransit. Okay? So far, so good. Easy enough to understand. Then we get to the line 20, where we are not using the bus. All we're doing is we're going to use Kafka, so we tell it to use the in-memory version of the bus. And then we get to line 22, where we're going to add a writer. Okay? This writer is then which one are we adding? So we add some Kafka components that have been added in here. These Kafka components do a couple of things, and I will really find my F12 in here in a moment. There we go. This is just a helper method that was included in this library that reads the relevant configuration information, sticks it into the appropriate thing, registers them into the services, and then makes sure that everything is wired up properly. Then it does the same thing for MongoDB so that MongoDB knows how to get its thing. And then it says, I want to add a consumer. A consumer is something that is going to process messages. Okay? This is our abstraction. This is our common way to write code. And by telling MassTransit about it here, we're saying, here's a class. I want you to dispatch all messages that you receive that it wants to it. Okay? So what does that class look like? This shipment manifest received consumer is simply a class that implements an interface called iConsumer. Okay? And it's an iConsumer of T, where that is shipment manifest received. That T is the message type that you are receiving. Okay? From here, it starts looking like business logic code, right? We have a private variable where we get a Mongo collection. We get that dependency injected on our constructor. And then we have the one method that iConsumer demands of us, which is a consume that receives a consume context of the message type we are receiving, and it returns a task. Okay? So give me the message. Give me an asynchronous way to say, I'll get around to it. Okay? So I can get out of this code. Okay? And other than that, no further constraints. Okay? In this particular case, as soon as we're in, we say, hey, go get me a session from the database using the why did it take us to C#8 to create curly brace-less version of using. Okay? Just desperately, desperately love the fact that we can now have using blocks, okay, that do not have curly braces and require everything to indent thereafter. Like, this was a quality of life adjustment we have needed for some time. Okay. So we're going to say, hey, I'd like to start a transaction against the database. And then we're going to say, for each product in the context we receive, go to the message on that context, because there's a lot of other things, metadata and other information on that context other than just the message. So go to the message. And then, in this case, go to the items inside that shipment manifest that we just received, okay, and start going through and filtering for them. And basically, this now says, I would like you to run a query to see if we've ever seen this before in the Mongo database. If we haven't seen this item before in the Mongo database, I want you to go ahead and add it to the Mongo database. If it's seen it before, then we're an item-potent system, because messaging systems should be item-potent. So just sort of smile, nod, send back, yep, we've got this. I got you. Big thumbs up. Did we do anything? No. But sure, I processed your message, right? So that is handled by build a filter, do a replace one async, sticks in, make sure that we have the current SKU, the current serial number, the current location for that product, stick it in, and then it passed the almighty bad defaults. This should be the default in Mongo. Is upsert true to say, I want you to find this, and if you don't find it, I want you to insert it. And if you do find it, I want you to update it. Okay? Hence upsert. And then commit the transaction, and away you go, using awaits along the way to make sure that all of those asynchronously long network operation-y things don't ever block our thread. Okay? This is what a consumer looks like. Most good consumers, apologies for those who are on projects that I introduced MassTransit to who violate this, I didn't do it. Most good consumers probably fit on a page, right? They should do a small amount of work and be done, okay? They should not be 10 pages of complex business logic. If they are, at the very least, you're missing a get that out of your consumer and go put it into a class whose purpose is whatever the heck that's going on there. Okay, because consumers are there exclusively to be the invocation hook, right? There should not be 10 page long consume methods, just like there should not be 10-page long post methods in an MVC application, right? We can all agree, get that out of there, go put it in another class. Doesn't belong in my controller. That's not my controller's responsibility. Leave me alone. Okay. Short, sweet, do the thing. Okay. So that's what a consumer looks like. And all we did back here in program is say, register that this consumer wants that message. Okay. This also has a state machine in it, because I mentioned that MassTransit has workflow. Okay. So you will not get very far in the world of building distributed systems before you're like, wait, I want to be able to have a thing and then have that transition to someplace else. And like somebody should be responsible for the current state of things. Okay. And so the good news is that MassTransit gives you an abstraction for this. The bad news is it requires something of us. So I'm going to admit, I have a fractional, like the first 2 years of a formal computer science education, okay? Beyond that, I learned the rest on the job because I will turn 50 this year, and so I am right in the sweet spot of it didn't matter that I learned to code on my own. The dot-com boom wanted to employ me, okay? So I got out of school and got into work. How many people here have a full, at least 4 years, bachelor's degree, formal computer science education? That number keeps rising. It's almost half the room at this point. Well done, guys. Okay, for everybody who didn't raise your hand, this is going to require you to have to get your head around actual state machines. Everybody who raised their hand had this in junior year. Okay, the concept of a set of states, each of whom have verbs that move you between the states. We spend most time in programming thinking about noun objects with verb methods, okay? State machines ask us to put this on its head, and start thinking about noun states with verb transitions that we move between. We go from received to picked when a pick message arrives. Okay, so we were in received, we are now in picked. Okay, we transitioned between the two. If you have that level of understanding, then MassTransit's state machine actually becomes pretty simple, because it allows you to go, there is an event called product picked. There is an event that can happen called container shipped in this case. And we could start this state machine when either of the following two things occur. When we get a product picked or we get a container shipped. So these events are just, as it happens, messages that can come in off of a stream for us. And we tell it how to correlate this to previous instances. The big thing here is that the correlation to previous instances. This allows when a product pick comes in and we go get the ID from the license plate number that is in that message, we are going to go and retrieve out of that inbound message its license plate number. And then we're going to go look in the database that backs our state machine and go, have you seen this before? And if the answer is yes, we're going to go, okay, then we are in some during execution, which is the next section down on line 34. If we have never seen it before, we are in the initially. If we go, have you seen this? And the answer is no, okay, then it's going to be like, okay, cool, we're in the initially block now. Is the thing that you just received one of these two things? Because we can initially, according to line 28, with a product picked, or we can initially based on a container shipped. Now, this is a very forgiving state machine that has been written by Chris here, okay? Even though, to be very clear, you must pick to ship, okay? He has written the state machine to go, I can start on either, okay? If, on the other hand, let's say we started on a product picked, and so we note into the database, we have a product picked. right? So context saga created right now. Let's do this thing, okay? And so the saga gets the saga then comes in and goes, when a product pick occurred, what do? I note that the saga has been updated. I place an order. I record an order number, a license plate number, the products, and I add all of the products in from that thing into the context of the state machine. And then I transition to picking. So I went from initially to we're picking. That happened like that. You were in initial for like microseconds, right? Because you're just copying data. If I get a container shipped during initially or picking, if I get a container shipped, right, then I update the license plate number, the carrier, and the tracking number, because we now have carriers and tracking numbers because we're shipping product, right? So we're sending this out on a truck. So we add in these two additional things, and now we transition to the shipped state, okay? So it is a simple two states. We are either picking or we're shipped, okay? Two-state state machine. That can go from pick to ship, okay? And should you actually find yourself in this situation of being able to create the, don't try to imagine how this happens, stream of events in real life, but this saga as described, if it received a pick it, ship it, pick it message, all for the same license plate number, it would absolutely go to picking, go to shipped, and then go back to picking. Because there's nothing in this code, simplistic as it is, that stops it from doing that. Because of the fact that he wanted to make it the sample as forgiving as possible. You would almost certainly have two during blocks and split so that product picked can only happen initially or in picking. It's this word that allows right here where we say this event can fire either of these two whens that are about to come. It's that piece that allows you to go from shipped back to pick. Okay? All of this is the saga engine of MassTransit. It exists solely to give you an example of how you can do it. This says use a saga state machine. Here's a state machine. It's about container state, and go get its MongoDB configuration from these things. Aha, that's the database name I was supposed to create. Remember I told you earlier I thought I was supposed to create a database? Let me go do that. Hey, Confluent Cloud. I need to add my own data. I need a database named Kafka demo. Okay, with a collection name called Kafka demo. Sure, that'll work. Do the thing. Cool. Now there's a database. All right. And then finally, we get to configuring Kafka itself for MassTransit. Okay? And what's happening here? We configure the host, we give it the context, we tell it that the client ID is backend. This is the key that is used to identify your offset. Okay? So I mentioned earlier that Kafka can keep track of your offset for you. This is how. Okay? And then it says, hey, I'd like a topic endpoint. I want to receive shipment manifest received from the events.erp topic. And when I am forced to reset my offset, I want to go to the earliest. This is, again, bad defaults that I mentioned earlier, right? Now I have to waste a line of code to tell you what I want you to do. I'm going to set the value deserializer to being an Avro deserializer, because this sample uses Avro. And I want only a maximum of 10 messages at a time. I want to have a retry, and I want to configure this to be delivered to this particular consumer. Okay? The next topic endpoint that we configure, and the only other one we configure here, is important because of the fact that it does something a little bit non-intuitive but very, very, very Kafka. Apologies. On line 56, we define a regular expression that speaks to the topics we want to subscribe to. We are not saying, here is a particular topic that I actually want to listen to. We are saying all topics that match this expression are going to be listened to and delivered to this consumer. This allows us to have events.warehouse. Any integer number that you care to represent, okay? Any sequence of 0 through 9 repeated over and over and over again, okay? And all of the topics that match that pattern will be read from, pulled through writer, and delivered to a consumer, to the same set of consumers in our mass transit code. Okay? So this shows how we can have a set of related streams that all have the same messages on them that we want to handle all of that consumption through one class. Okay? And not have to worry about creating lots of configuration, having to individually subscribe to every single topic. You could just be like, the pattern of their names looks like this. This is the one that kicks off the saga, so it goes down here eventually to the saga. Now, before I go any further, because I do only have a little bit more time, and I promise I am going to open Postman, run this code, and actually do it. But I swear, having questions, if you have any questions about this, this is the important stuff to wait on. So, did any of this not make sense to anyone here, given the state we've had previously? Yeah. Yeah. You can use anything to back any database to back a saga that you would like. All the popular ones already have written, but it does expect the ACID semantics when it says commit this state of the state machine. It expects the ACID semantics around that. Yeah. Does that make sense? Did I answer your question? You have this look like I might not have answered your question. Well, I mean, even Mongo, like Mongo is only consistent within a document, right? Which is why everything it's doing here is read, write, or upsert a document, right? Like that's where it keeps it to. So you can have, certainly if you said, hey, I'd like to write this across 3 Redis keys, don't do that, right? Like as an example of something that you can't guarantee would be following the correct patterns there. Yeah, so the big thing here is that this is a convenient model. It's forcing you to think about your data processing. Like this doesn't do anything but to give you a model in which is known and successful for dealing with your data processing, okay? And one of the nice things is that MassTransit already has built in the necessary pieces to stop you from launching 2 instances that are attempting to talk to the same state at a time. So this won't happen in Kafka. This could happen in a queued situation, where two messages that happen to be adjacent to each other in the queue in a competing consumer situation both start getting processed, right, by two different processors, both of whom want to go update the state of a state machine, right? So they're each going to go check the state of the state machine and do this thing, right? It already has the defensiveness built in to make sure you don't run into a challenge. So. Yeah. Yeah. Correct. Yep. So, all right. So I have managed to get my code up and running. I pressed F5. Serolog is nicely telling me that we have connected, that we have figured out that there is a partition and that we have assigned it to backend and a big GUID in both of these cases to be able to track who and what are reading. All right, this is really nice, but unfortunately this backend doesn't do anything unless there's actually something else going on. So we're just going to shut this down and now set this to start multiple projects where we're going to start both backend and the web front end for this, the warehouse API. And this time when we start this up, we're going to get, yes, entrust the certificate. Yes, install the certificate. Thank you. Awesome. Okay. That launched up. Okay. So Chris gave us a wonderful Swagger interface for us here. So this is our backend running. This is, hey, I'd like to potentially receive a manifest and look at all of this wonderful stuff. They're like, this is the message you sent. So I'm just going to grab this, and then we're going to come down here and say, I would like to try this out. And it will give me this example. So source system ID, some fancy system. The event ID for this event, we're going to call this developers are cool. We are going to have a timestamp. I will leave the default timestamp. We will have a purchase order number, PO123456, and then a delivery location of 47. And now we have an array of products that we're trying to send here. Let me make this font a little bit bigger because I'm sure that's unreadable in the room. There we go. We are going to send an array of products, each of which needs a SKU, 1, 2, 3, 4, 5, 6, 7, and a serial number for that. We're going to just name this something like Apple iPod 99, okay? And then let's send one more of these along, not making the JSON mistake that it wants me to make. So let's just slide all of that forward by one, and then we'll name this one Microsoft Zune 99 because nobody in here remembers a Zune. So we're going to go ahead and send this in to our application. We're going to click execute, and it will say, hey, I got an error. The event ID must be a string or an array type with a minimum length of 24. This is a nice way of saying it wants a GUID there. That one. Copy a GUID. Okay. It wants a GUID there. Let's just give it a GUID there. It's like I have tools built into my developer stuff that let me easily generate GUIDs. Okay. Yes, yes. Without the oops, do an execute. And all right. So we got a 202 response. And then back here, we received the call to events.erp, sample contract shipment manifest received. So we got a shipment manifest in, we have processed it. Let's go look at data. We've been very good. We have data. So we have product location now. And in that product location, we have two different things, an Apple iPod 99 and a Microsoft Zune 99 stored into our work. So message HTTP post went into our API. We published the topic, show that in a moment. That topic was being monitored by our backend received it, grabbed that message, grabbed the details of the message, shoved it back into this database. So let's get past the there be magic portion of this. Let's look at the ERP events that had just happened and go look at the messages that are here. And we're going to come in and say, I want to start at offset 0. And voila, all of a sudden, there is literally the message we just wrote. Because, sorry, that's too big. But that is our message as sent in, literally the JSON body that we just sent in that got recorded onto our topic and processed. Now, we saw earlier that this is in fact an upsert, right? So we can execute this 3 more times, come back over here, and if I come in and say, there is no magic here, go back to topics, go back to events ERP, go back to messages, and go to offset 0. Each time I did that, there was a new message put on the bus, or onto the topic. Pardon me. Onto the topic. But what didn't happen is, if we come back here and say, please go ahead and query for all the documents in here again, we still only have 2 documents here because of the fact that our business logic said we have this already, just update it, right? So we've received this same shipment 4 times. We will always receive this shipment 4 times every time we go back to offset 0 and read through this scanning. Okay? Which, to be clear, might be a perfectly workable solution depending on what you're working with, right? Sometimes terseness wins, or sometimes, most times, terseness should win over speed. But sometimes, certain scenarios, speed wins, okay? If you're taking, I don't know, toll tag reads off of the highway, and your cars are passing through the RFID fields. Often, most times, your toll tag pings out to the antennas on the RFID multiple times as you pass under those gates, because it gets energized and transmits and energized and transmits and energized and transmits as you move through the electric field that is causing the RFID to do what it is doing. And so the receiving system is getting lots of data. The North Texas Toll Authority, the NTTA, believes it is very important that we record that a thing occurred, right? And very much not important, they'll deal with the dedupe of, I got 3 reads all within a 2-second pass of a car. If their event stream says, Tim's car went through the Bush toll gate, 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 Mark's car went through, Mark's car went through, David's car went through. They're like, we'll figure it out. Just get it recorded, right? So a decent situation for stick it on a Kafka topic. Just go and move and do your thing, all right? So I can go deeper, but this is the walking skeleton walking at this point. Questions at this point to how that consumption pattern went? I think the piece of code that we just executed that I haven't shown you yet is merely the publication in the web API. So if we were to go here and say in the receive controller, all that happened in the receive controller is we said, hey, give me a topic producer from services and produce onto that topic and dump all the data we just got in from the details received on your post and produce it out onto the topic. So that's how you produce. That's how you consume. Now just go solve business problems, right? This is where everything else you can delay and worry about later, right? All the error handling, all the things like that. MassTransit's got built in. They have a solution for it when you have the need for it. It gets you off the ground and running and working with a solution faster than anything else for building your distributed systems like this. Yes. I have not spent much time with Dapper in this space, and I know that there are a large number of interesting things that have then been laid on top of it, right? To like I know Tony Sneed, who's local here, has a service bus implementation on top of it. Okay, so I have not spent enough time with it to do a good compare and contrast there, to be honest. Yeah. And to be clear for those in the room, he is not talking about the micro OR. This is the worst name collision in .NET at the current time. The fact that there is a messaging implementation and a super popular micro ORM who happen to share a name. Yeah, it doesn't. See that is a pre-1990 argument, right? We live in a world where how things are said matter, right? I don't care that you're dig with 3 Gs, right? I'm going to say dig, and I'm not when your radio advertisement runs or even your television advertisement runs, and I hear dig, I'm going to go to the wrong website. Okay, names matter. Okay, dropping letters not helpful. Okay. Yeah. Yes. There are unfortunately 2, and so I wanted to clarify because you might be going, you might reasonably be going, databases are in queues. Like I've heard Tim give that preach. I'm like, no, that's not the question that just got asked. Yeah. Yes. Loses a P, loses an E, right? As opposed to the DAPPER micro ORM. So, any other questions? Yeah, so it already has SQS, Amazon SQS. It already has Azure Service Bus. Okay, those are supported by Chris directly. Okay, on the library. It's probably its hands down most popular is RabbitMQ. Okay, for sheer popularity, but that's not a requirement. That's just a popularity thing. All 3 of those are shipped from Chris. There is WebSphere and one other who I'm forgetting that are community maintained that I'm aware of. Okay, so there are at least 2 other transports that are maintained for it. It no longer supports MSMQ. Like NService Bus, they've looked at that abomination and went stop it, and so they stopped it. It did used to, yes. So a single bus object for mass transit is only on one transport mechanism. Okay? You can configure multiple buses, okay? And then you would simply have to, inside your DI, be clear which one you are receiving, okay? Or which one you are intending to publish to, okay? When I have been in situations like that, where I want to publish to multiple things, it has been, when I have started, I have often been able to sell myself the bill of goods that I want bus 1 to see everything that bus 2 sees. In reality, over time, I come to the opinion that no, I don't. And so what I need is, there's probably a directionality here, right? And I need to build a consumer that consumes from one bus and publishes to the other, who is my gateway for the particular things that I want to publish. Now, I mentioned earlier, nice generic abstraction for handling message consumption. And I gave you the nice, pretty version that, to be clear, everybody who has actually written mass transit code in this room will tell you, you write I consumers of T all the time, okay? But you don't have to. It is possible to write an I consumer of just give me all the messages, okay? And so you can do the bus shoveling that I just described by writing a consume process who consumes very broadly, okay, and inside does its logic to determine, right? You just don't get static typing on your inbound message while you do that, okay? But static typing versus thousands of lines of code, I'll give up static typing and write something that just moves payloads without necessarily caring what the static type of that payload is, right? So just like you can write filters in MVC that see every HTTP action, regardless of what its verb is, regardless of what its route is, right? You can stick middleware in the middle. You can do the same thing for the mass transit receive pipeline, okay? Other questions? All right, awesome. Well, I'm going to shut this down because I've certainly gone long enough. I will be hanging around and be happy to talk to my heart's content and then some on mass transit afterwards. Thank you all for coming and paying attention to me. I very much appreciate it.